Hello again, and this is Danny Klein starting up your second video for Calc 1, Section 1.1. Again, this is going to be on limits, and you'll notice I have a similar setup to what you've seen already, but this time the function is slightly different. You'll notice it looks kind of similar to the second function we had last time, but there are some differences, and we're going to see what happens when we work through that here. So I'm going to start off by making a note for you here. This is our function, which is absolute value of x squared minus 4 over x minus 2. So that's over the whole thing, x minus 2. Now, this is pretty similar to what we had last time, except that top we didn't have an absolute value last time. And what we're going to do is something similar to what we did last time. And you can see I've already got the chart broken up into two pieces. And you might, by looking at these functions right here, you might even be able to tell why I have the second function broken up the way I do. Why I have these values in particular right here instead of picking some other value to center around. So we will see that here in a second. There we go. Don't need that anymore. Don't need that. Don't need that. All right. So what we're going to do is I'm going to do exactly what I did last time. And I'm going to give you all a little bit of time to fill out this chart on your own. Let's see, right there. So this first chart you should be able to fill out without too much trouble. I'm going to, hopefully, after I set this up, I'm going to just write out the values for most of these, but I will work through at least one or two to show you what's going on. So what I'd like for you to do is pause the video, and when you come back, we can work through these together. So go ahead and pause this video and work through these ones by yourself. Okay, if everybody's back, we can go ahead and start. Now, it is important that you get the function right. If you don't get the function right, you have to make the whole video over again, so you do have to be careful about that. So this first one, we should have, hang on, absolute value of negative 3 squared minus 4 over, on the bottom, negative 3 minus 2 over that whole thing. So if we look, that matches our function up above, negative 3 squared minus 4 over negative 3 minus 2. If we square negative 3, the important thing to remember there is squaring negative 3 is multiplying negative 3 by itself. So that gives you a 9. So I'm going to get absolute value 9 minus 4 over, what did I have? Negative 3 minus 2, which should be a negative 5. If I do this all out, I should get on the top 9 minus 4 is 5. Absolute value of that is still 5. On the bottom, negative 5. And if we divide that, we should get negative 1 right there. Okay. Hopefully that makes sense to everybody. We'll do the next one as well. Let's, hang on, we'll get this one here. Negative 2 squared minus 4 over negative 2 minus 2. Well, if we square negative 2, that's going to give us 4. So on the top, I'm going to have 0. At that point, it really doesn't matter what I have on the bottom, although in this case it's 4, and that works out to be 0 here. We can keep going from here. You do have to do each one because you can't always predict what they're going to do. So next one, I'm going to get negative 1 squared minus 4 absolute value over minus 1, minus 2. The top then becomes 1 minus 4, which is negative 3, but absolute value of that is 3, over negative 3. And if I work that out over here, I should get another negative 1. So already you can see, unlike the graph that we had last time, these values are repeating themselves. So there's going to be some bouncing up and down going on. We don't know exactly what it is just yet, but we should be able to figure it out pretty soon. Then we're going to have 0 squared minus 4 over 0 minus 2. That's going to give me 4 divided by negative 2 on the top, which is going to work out to be a negative 2 here. The next one is 1. If I do that one, I'm going to get 1 squared minus 4 divided by 1 minus 2. 1 minus 4 is 3, or is negative 3. Absolute value of that is 3. 1 minus 2 is negative 1. So this one should give me, if I work it all out, negative 3. Okay, so those ones are done. Those first. Now, at this point, you might have noticed that this 2 value right here that we've got here is also the center of our second chart. So you might be expecting something unusual to happen here, and as we can see it will. On the top, we will get 2 squared minus 4, and on the bottom we'll have 2 minus 2. I should have parentheses up here as well. Let's go ahead and put them in. Now, if I take 2 squared, I get 4. 4 minus 4 gives me 0 on top. 2 minus 2 gives me 0 on bottom. In any case, I'm not allowed to do that. So what did we call this kind of situation last time? If you'll recall, hang on. There we go. Let's put it in red here, like a big warning. Undefined. There we go. Okay, so this one is undefined. So we run into that issue again. And you might expect that that's where our question about the limit is going to be. Now, this next one here, hang on. Didn't need to zoom away from me like that, but let's go ahead and get back. So we get 3 squared minus 4 over 3 minus 2. Let's go ahead and fill all these out. 4 squared minus 4 over 4 minus 2. 5 squared minus 4 over 5 minus 2. And finally 6 squared minus 4 over 6 minus 2. This is just some quick arithmetic to do here. We can do this out. 9 minus 4 gives me 5. 3 minus 2 gives me 1. 16 minus 4 gives me 12. 4 minus 2 gives me 2. 25 minus 4 gives me 21. 5 minus 2 gives me 3. And finally down here, 36 minus 4 gives me 32. And 6 minus 4 gives me 4. If I plug those all in and divide, 5 over 1 is 5. 12 over 2 is 6. 21 over 3 is 7. And finally, 32 over 4 is 8. That part works out just fine. And so we can use these values right here. Here, 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 to plot points on our graph again. So let's go ahead and do that. Our first one is negative 3, 1. So if you'll remember, negative 3 in the x means we go backward 3. Negative 1 means we go down 1. So I should have my first point right there. My next point is 0, negative 2. That means, hang on, nope, my next point is negative 2, 0. That means I go backward 2. and stay on the axis, so it should be right about there. The next one is -1, -1, so that means I go backward 1, down 1. The next one is 0, -2, so that means I stay on the y-axis this time and go down 2. And finally, my last point is 1, -3, so I go forward 1 and down 3. So those are the first points that I get here. Let me try and make them big enough that we can see what's going on here. All right. We could have put more in there. You never know exactly how many points you're going to need. Next, we'll do 3, 5. So that is over 3 and up 5, which, if I'm careful here, I can get this right. 3 and up 5. Should be right about there. The next one, if I remember, was 4, 6. So that's 4 up 6. The next one is 5, 7. That is over 5 up 7. So those are all the points we got. Now you'll notice this doesn't look at all like the graphs we saw last time. The ones we saw last time were pretty much just straight lines. But this has a lot of weird things happening. In fact, the way we're looking at it now, you might almost think that it has too many weird things happening. But if we remember that we had this one value here, the 2, which was undefined, means I should expect something unusual going on in this x equals 2 bar here. So x equals 2, that's where our undefined values are. So we should not necessarily worry that something weird is going on there just yet. And with that out of the way, you can actually figure out what is going on with the other points by connecting up how they look like they're connecting. So it looks like we're getting something that's more or less a straight line here, and something that's more or less of a part of a straight line there. And if we look up here, we only have these 3 points, but if you even think about the one that was further on, we can see what we're getting here is also a piece of a straight line. So we're getting some pieces of a straight line. If you notice, the left-hand side of this comes to that sharp point. And for those of you who've done some graphing in a pre-calc class, you might remember that that's the general shape we see for absolute value graphs. And if you might remember, they called this by a specific name. I don't know about this one. Okay. What did we call this? Anybody remember? Rabbit ears. Sometimes you'll hear. These are upside down rabbit ears, but that is what we have there. Okay, so something like, not too far from this. Something like that. That's not a specific rabbit, that's a general rabbit. So anyway, that is roughly what we're getting there. We're getting rabbit ears. Now, on the other side here, we're getting something a little bit harder to deal with. We have this 1.5 value here. I need this back on blue now, I guess. We still have to plug this into the same equation we did before. So x squared minus 4 over x minus 2. So what I'm going to have you all do is, again, we've already done the 2, but these other 4 values, pause the video and plug those into x squared minus 4 over x minus 2 and see what you get. These will be Much easier if you use a calculator. So do that, and I will come back to you as soon as you unpause the video. Okay, so if everyone is back, we'll actually do this out. We get, hang on, absolute value 1.5 squared minus 4 on top, and on the bottom we have 1.5 minus 2. Those aren't absolute values there, though. That's just parentheses. In fact, before I do any more of this, let's actually write out these formulas for all of them. Next one's the same, except these are 1.9s. Remember, we're using this to get close to the 2 value. So 1.9 minus 2. And on the bottom, we're going to do the same thing, except these are slightly to the other side of the 2 value. In other words, here, 2.1 squared minus 4 divided by 2.1 minus 2, and down here we have a 2.5 squared minus 4 over 2.5 minus 2. Okay, so we can work these out. These are much easier to do on a calculator than by hand. I'll try and do at least the top one by hand. I should know what these other ones are because I know what they should work out to be given the graph. So, but let's take a look. 1.5 squared is 2.25. 2.25 minus 4 is negative 1.75. So here we're going to get 2.25 minus 4 on top. Absolute value of that over on the bottom, 1.5 minus 2, that is negative 0.5. Okay. The nice thing about that is it's going to make it easy to divide, and I'll explain why in a second. So here, 2.25 minus 4, that's negative 1.75. So if I put that on top, put it in absolute values, I should get a positive, then divided by negative 0.5. If I work that out, well, dividing by 0.5, 0.5 is a half. So dividing by a half is the same as multiplying by 2. If I multiply 1.75 by 2, you don't have to do too much here, but plug it into the calculator to get negative 3.5 there as your answer. Negative 3.5 for that one. We can do the same thing for this next one. 1.9 is a little bit harder to do in your head, but we should be able to get it. Anyway, let's plot this first point. That's 1.5, so halfway between 1 and 2, and we should get negative 3.5. Negative 3.5, so right about there. Looks like it continues the straight line about as we would expect. And the last one here, 1.9, if we square that, that's what, 3.81. I believe. Hang on. I might have to shrink this again so I can get the numbers in there right. Hang on. In any event, let's see. Okay, let's do it by hand, just to make sure I'm not making a mistake. 1.9, 1.9, 81. Hang on, not 81. 171, 19. I was almost right. 361. There we go. So 3.61 I would have been able to tell if I was wrong at the end because of what it should be. And here on the bottom, I should divide by, in this case, negative 0.1 instead of what I had before. So, negative 3.61 minus 4 is going to give me, what, about, well, exactly 0.39 over negative 0.1. If I work that out, I should divide that through on a calculator or wherever, I'll get a 3.9 there. You don't always need to do this. Let's get rid of that because, why not? So negative 3.9 continues that line exactly as we would expect it. In other words, hang on. This line seems to be continuing as we get closer and closer to 2. I'll leave it be for a moment, but we'll go back to see what we expect there. If we continue on the other side, 2.1, this is 4, if we square that, it's 4.41. Sorry, let's make that 4.41 minus 4, divide by 0.1, work that out on a calculator, you're going to get, hang on, I messed up, you're going to get 4.1. We can do the same thing down here. We're going to get 2.25 squared, that's 6.25 minus 4, absolute value, divided by 0.5 this time. That's 2.25 times 2, which should be 4.5 this time. Again, if we plot those out over here, we will see that they continue this straight line exactly as you would expect it to. So right down to there. Now, what we're going to look at here is we see this straight line keeps continuing. Now, this only gets us so far. We could continue this process with, again, like a 1.99 and a 2.01 to get even closer, but we're still not there, so continuing this process over and over isn't going to add much to it. What we will have to do is just understand that this is approaching, like we saw last time, approaching this value right here. We're not filling it in just like we didn't last time because it never reaches that value. This one approaches that value. So you can see what point they're approaching. So you'll remember we saw at 2, we don't even have a value. It's undefined, right? This is undefined right here. So we don't have a value there. But we see we're getting close to those 2 points from either side. And so what we have to do here is figure out, what does this mean for the limit? This is a little bit different of a situation than what we had before. So you'll remember how I set these up before. Let's go ahead and put this back in black. I had the limit as x approached some value of f of x, and I wanted to be able to say what number that was. Here, the number I want to approach, obviously, is 2. If I were approaching any of these other values, there wouldn't really be any question of what's happening, right? So, for instance, if I approached instead of 2, if I approached instead of 2, I approached 3. Well, there's not really any question. I approach 3 from one side. If I'm approaching 3 here on the x, either direction, the y value I'm getting close to is the y value here at this point, which is 5. So if I see that, I would have the limit as x equals 3 of f of x goes to 5. So that's not a problem. However, the place where this fails, it fails a little bit worse than the one we did in the last video. So in other words, if I'm looking at the limit as x goes to 2 of f of x, you will notice that let's get rid of those. If I'm going to 2 this way or this way, I wind up with a very different result. If I go to 2 from the left, so in other words, from the left here, I'm approaching this point on my graph. I'm approaching that point. If I go to 2 from the right, I am approaching this point on my graph. So I'm approaching those y values. But those are two different y values. In other words, up here, I'm getting the y value of, what is this, 4? Yeah. 1, 2, 3, 4. So this gives me a y value of 4. That's what I'm approaching as I go to 2 from the right. If I go to 2 from the left, I'm going to get a y value close to -4 right here. All right? Y equals -4. So in this case, not only does the function not have a value, we can't even really say what the limit is unless we talk about specific directions. So we have a little way to symbolize this. Let me write these out and then tell you how we say them. I have these two different ones here. So this first one, if I want to describe what I mean by that little minus sign, I would call that from the left. That minus sign means from the left. In other words, from smaller values of x. The second one, the plus sign, that means from the right. So from bigger values of x. So here, if we let our x value go towards 2, from smaller values of x, our y value goes toward -4. If we let our x value go toward 2 from bigger values of x, our y value goes toward 4. And what this then means is, we get these two values here, but if I want to ask about the limit just as x goes to 2 of f of x, I don't have a value anymore. It's approaching two different values from two different ways. And what that tells us here is we say that this, like the function value itself, is undefined. So in other words here we say, if we want to do it out here, approaches two different values from different directions. And that is what we wind up finding here. So when the limit does this, when we get two limiting values, one from the right, one from the left, and they are not the same, we say that that limit is undefined. So that is what we're going to wind up with here. Let's go ahead and, I think, stop it for there. That should get us through pretty much what we need in section 1.1. And you can rewatch these videos as much as you need, As I've said before, I will be posting more of them, and I will be trying to post these PDFs along with them, so you'll be able to refer back to them as much as you need. If you have any questions, feel free to email me, and I'll be happy to answer, or we can talk on chat, which I'll be sending you those links tomorrow. Okay, thank you very much, and I'll see you soon.